Welcome to the Pipeline Patterns to Aid Your Next Deployment talk in the Builders Track at AWS Summit Sydney 2023. My name is James Ousby, and I'm joined by my colleague Bryn Price, and we are both solutions architects with AWS here in Sydney. So here in the Builders Track, we love to explore new ways to help you build software. What is just as exciting though is the ability to put that software safely in the hands of your customers. Today we are going on a whirlwind tour of 4 key patterns that you can use to level up your software delivery pipelines. Most of us at some point in our careers as software developers have had a moment where we have wondered if perhaps the grass is greener somewhere else. The thought that somewhere there is a development team that is releasing to production multiple times a day, has 100% test coverage, no one ever breaks the build, and code flows seamlessly through multiple environments has crossed our minds. And I think this is really healthy. As software developers, we should be continually questioning how we execute our craft and striving to move towards what we know is possible. There are definitely some development teams who are living the dream, but for most of us, we're on a journey. As a solutions architect at AWS, one of the most interesting parts of the role has been getting to see how a diverse set of AWS customers go about building and releasing software. And the reality is that for most of us, the companies we are working for are still relatively early in their journey towards automated release, testing, and operational processes. And again, this is fine. The main point that I'm driving towards in these introductory slides is that wherever you or your company are at in this journey, the important thing is that you are not standing still and are taking steps to move forward. One of the most common questions we get from customers looking to improve their developer experience is, well, how does Amazon do it? How does Amazon automate software delivery? And no one really likes to hear the answer that we have a large team of full-time engineers who focus exclusively on build tooling and developer experience. And they've been chipping away at this for over 15 years now. Amazon has close to 500,000 pipelines that turn over 250,000 builds per day. But what's interesting about talking to the builder tools team at Amazon is the acknowledgement that things are far from perfect. There are gaps in capability, there is technical debt, and there's always more ways they can be working on and ways to improve release safety and improve the developer experience. You don't have to have full-time developers working on build tooling to make some progress. Maybe it's a percentage of each sprint, or dedicated sprints once a quarter. There are multiple models that work, and I hope you leave today's talk keen to make a case to invest more in pipelines and developer experience. But let's get to the fun stuff. The 4 key patterns we're looking to cover today are how to upgrade the observability you have around build tooling, how to manage data-related changes from your pipeline with schema evolution and migration tools, how to test in each pipeline run that your code has the resiliency you expect, and finally, how to adopt pipeline managed feature flags to make your releases even safer. All of the patterns we are covering today can be implemented with the build tooling you are using today. To bring home this idea, we have implemented our demos using GitLab CI/CD. The application we are using to demo these patterns is a basic API for a to-do service that supports standard CRUD operations. The architecture looks as follows. We have an API gateway that defines the RESTful interface. We have a number of Lambda functions that implement the CRUD operations. And then we have a relational database that is set up in a multi-AZ, highly available configuration for storing our to-do items. So the more suitable option for this use case would be to use a data store like DynamoDB. However, we know that customers often struggle to manage relational databases from pipelines. So using Amazon RDS here allows us to better demonstrate some of the patterns we wanted to cover. Finally, I'd like to cover what our starting position is for a basic pipeline that we'll be improving upon during the talk. Firstly, our pipeline has preliminary steps for running the build and unit tests, and then deploying to a dev environment. Next, we run some end-to-end tests against the deployed environment to further check for correctness. We have a manual approval gate for allowing the release candidate to be promoted into higher environments. Then, after moving through a number of other environments, we have a production deployment step, and a set of deployment checks that verify that production is functioning as intended. So that's our baseline. Now I'd like to hand it over to Bryn to cover our first pattern on pipeline observability.
Thanks, James. So look, many organizations don't track their pipelines, or they only do so in isolation, without that view of the bigger picture. This lack of visibility really makes it difficult to kind of measure performance and identify those areas for improvement and help you with those understanding and building on those long-term trends. Consider the boiling frog analogy. If you put a frog in a pot of boiling water, it's going to jump out straight away. But if you put that frog in at a room temperature and you turn that temperature up slowly, it stays there and slowly gets boiled alive. So too are the inefficiencies in your build and deployment processes. They might not be a big deal on their own, but they can add up and cause significant problems. As your business grows and your number of pipelines increase, it's even more important to make sure that you've got visibility at that macro level. By doing so, you can understand those trends over time and make data-driven decisions to make sure that you've got product improvement and that your software development teams are performing optimally. As an engineer, have you ever struggled to get your development project off the line? This is where you get the data points to help that. Thankfully, many of the CI/CD providers have an exporter already available, or there's one available in the community, so it's very easy to get started. The important thing here, it's less about the tool that you're using and more about actually capturing and acting on that data. Best practices that you have for managing your production application observability should also apply to your pipeline. So if you're using existing tools or services today, use those same tools to monitor and observe your pipeline. For our demo pipeline that we've implemented in GitLab CI/CD, we've used the GitLab CI pipeline exporter, which is available in GitHub. And that's running as a container in AWS Fargate. And then we're taking those metrics, storing it in the Amazon Managed Service for Prometheus, and visualizing and acting on that data through Amazon Managed Grafana. Here's an example that you can see of one of the screenshots of the dashboards that's actually available with that exporter, giving you quick and easy visualization of your pipeline health across multiple pipelines and executions. So don't be like that frog and boiled in water. Add a task to your backlog today, implement observability, and act on that data that it provides. Back to you, James.
So one of the big challenges we see customers facing when looking to adopt automated pipelines is how to safely roll out schema and data migration changes in lockstep with associated software changes. Sometimes customers have internal controls that mandate database changes are made prior to a software deployment by a separate team or separate tool. Pipelines are used to make software changes, but there is a clunky human ceremony required to make data changes. At a high level, just like taking humans out of the loop when automating software changes leads to more repeatable and more deterministic outcomes, the same applies when making data-related changes. Having an automated process to ensure that your software and codependent data-related changes are deployed together is what you want to be striving for. There is a family of tools under the umbrella term of schema evolution or migration frameworks that make applying schema and data-related changes in an automated and deterministic way much easier. These tools are not new, and often you'll find them baked into your favorite web framework or open source application. Whenever you do a version upgrade of these applications, you will see it automatically run an upgrade of the underlying database that it uses to support new features in the product. You can use these same tools to apply a similar process to your data stores from your pipelines. Let's start by having a look at the initial challenge in rolling out our to-do application using AWS CDK and AWS CloudFormation from a pipeline. AWS makes it easy to provision a database instance from CloudFormation. It makes it easy to provision our function code. But what we are missing is the database schema that includes tables, indexes, and views that our code is expecting to interact with. How do we bootstrap our database instance in an automated way? One approach is to break up the deployment into 3 stages. In step 1, we deploy the database instance. In step 2, we run a shell script from our build runner that applies an initial schema to the database. Then in step 3, we deploy our code and it initializes at a point when our database is ready to receive queries. But we can do much better than rolling our own mechanism for applying SQL scripts. This is where existing schema evolution and migration frameworks can help. These tools provide semantic conventions that make it easier to be more deterministic about applying and rolling back changes to the database. To drive these tools, you check in sequentially numbered files that incrementally apply your changes. When the migration framework runs, it checks to see if there's a migration file with a higher number than the currently maintained high watermark, and if so, it applies it. As an example, if we're rolling out version 2 of our to-do application, in a single commit, we push both our schema migration changes and the associated application code that uses the tables and columns that we've added. This is the most important benefit of using a migration framework. We can review all the changes needed for a feature as one unit and be confident that they will move together through an automated pipeline that will test the deployment process several times before trying in production. We see when the migration tool runs in the pipeline, it checks the current high watermark, which is maintained in a special table in the database, and notes that it is at version 1. It sees that there is a higher version script to apply in version 2, which it applies, and then updates its high watermark in that special table to be at version 2. And finally, we deploy version 2 of our application, where it starts running when the database is ready to receive version 2 queries. It can be a little clunky having to break up your deployment step into 3 stages though, with a CloudFormation stack for the database and a CloudFormation stack for the application layer. CloudFormation custom resources are a relatively new feature that allows you to run arbitrary code via Lambda functions as part of your CloudFormation deployment. We can use a custom resource to execute the migration framework as part of the CloudFormation service provisioning step and collapse all this back down into a single step in our pipeline. As an example, if we are deploying another version of our to-do app, we make our unified commit of application code and database changes. And then from a single deploy, the CloudFormation service is responsible for sequencing the creation of the database, running the migration framework from the custom resource Lambda function, and then deploying the application code. And we'll see an example of this pattern in our demo. So for the demo, I'm using a framework called Migrate. So this is a Golang-based binary. It has support for loading migration files from S3. You can check that out on GitHub. And the starting point for the demo is version 1 of the API is deployed, but it's quite simple. It allows you to create a to-do item with a title. We've got a create operation here and a list operation. And the goal of the demo is to add a version 2 where we add a description field. So in the VS Code here, we've got our schema migration files. You notice they come as a pair. So version 0, there is a script to create the initial table, and there's a script to tear it down. And then as part of adding our version 2 feature with a description column, we've got a version 1 there. We've got a crate that adds the column, and then a script that tears it down. And then we also need to make the associated changes in our data access layer. So we add in support for the description column in our data access code. And then the other thing I wanted to show you is the infrastructure as code for this application. So here we have CDK-based application infra as code for deploying our database. And then next we have this CDK construct that is our CloudFormation custom resource that is running the migrate function. So I wrote this construct for the demo. We're going to share the code for this at the end if you want to grab the QR code for it. And we'll see that in action in a second. So you will take those migration steps, run it through the migrate framework as part of the Lambda function in the CloudFormation provisioning step. So we run all that through our pipeline. You can see here we have a single deploy step that is going to be provisioning the database, running that custom resource that runs the migrate function, and then deploying our code. And we can check that the migrate function ran successfully by going and having a look at the logs in the console. We can see that the migrate function ran okay. It's applied version 0 and then version 1 of the schema successfully. And now if we go back to our test script and we try to pass in a description field as part of the to-do create, we can see that comes back as part of the create. It also comes back as part of the list operation. So there you have it, schema evolutions applied as part of a pipeline. Okay, back to you, Bryn, to hear about our next pattern on resiliency testing.
Cheers. So look, chaos engineering, it's the act of introducing failures into a system to test their response and discover flaws before they cause you downtime in production. It's an evolving practice that really allows engineering teams and developers to take ownership of their application software reliability. Even though automated CI/CD pipelines allow us to do fast product iterations with unit and end-to-end tests, we don't have an ability to get all the application's failure modes. This is really kind of where chaos engineering intersects with developer ops. So for our demo pipeline here, we've introduced a resiliency test stage. I'm going to use the AWS Fault Injection Simulator to run an experiment for us. In our case, we're going to cause that Amazon RDS database to fail over to the secondary node. And then we're going to test to see how our code behaves. In this case, our code's not behaved as we've expected. So perhaps there's a case where we're using a connector library or our code structure doesn't handle that loss and reconnection. So in this case, any in-flight insert or select statements actually hang our code. Or in our case with Lambda, we'd have a Lambda timeout. This is really useful information, not only for us to go and then make corrective actions to our code or our code structure, but also help us to define those Lambda functions. So let's dive into some code and see that in action. Here we are in our GitLab CI pipeline code definition, defined in YAML. And I'm going to add in here an additional stage and job for our resiliency test. For our resiliency test, what we're going to do is we're going to grab that ARN target of that primary Amazon RDS database, and we're going to use the CLI to send that off and update the template. I've then got some Python code there that's going to start that experiment for us, and then go and actually determine, based on waiting at an amount of time, and then executing the Lambda function, whether things have actually occurred as we expected. So let's push our code and run our pipeline. And we've got a failure. All right, let's dive into that and see what went wrong. As we look at our code here and we see the output from that Python function, we can see that we ran our experiment. We can see the experiment completed correctly. So from a fault injection perspective, we've managed to fail over the database. But we waited 120 seconds and we tested our Lambda function again, and we got an internal server error. So there's a problem there. So as a developer, I go back and I look at my code. Now, I wrote my Lambda function with the connection code outside the Lambda handler. Now, that's great for performance, but it doesn't help when the database changes location or fails. So in this case, we need to do something to correct that. In my case, I'm going to use the Amazon RDS proxy, which not only provides us with additional resiliency and service capability, also means I don't have to update my code. So let's roll that into our CDK stack, make the changes there to include the proxy, and push that change through to the pipeline. So now as we run through our code, we're going to rerun that experiment, now with RDS proxy in place. And we've got the green tick. I'm always happy when my pipeline's successful, but let's go and have a look at the code and see if that actually worked. So again, we can see that we've run our RDS experiment. We've seen that that's completed and failed over. We've waited that 120 seconds, and then we've made our call, and we've got our to-do list back. So we're now happy that our code functions correctly. Over to you, James.
So feature flags are a relatively new capability in software development. They weren't around for most of the time that I have been a programmer, and for most AWS customers, it's still early days in their adoption. We could do a whole talk on feature flags, so I just want to make it clear that today we are just hitting the highlights, and we are focusing on how they can make automated releases via pipelines safer. How feature flags work at a high level: you have a configuration object where you define your flags and whether they're turned on or off. You update your application code to have conditional logic that only executes code related to a feature if the flag is enabled. And crucially, during runtime, your application periodically checks to see if that state of the flag has changed and executes its conditional code accordingly. Maybe up until this point, you've only thought of feature flags as a way for fancy web or mobile apps to expose premium features to their customers. They are great for this use case, but feature flags have a much more general applicability in being able to de-risk any software change. Even with an automated software delivery pipeline, it might take you up to 30 minutes to diagnose a problem and roll out either a fix or roll back. Whereas with feature flags, you can turn on a feature for a small subset of users or customers. And if you encounter an issue, you can have an alarm that automatically rolls the feature back in seconds. Let's take a look at how we might incorporate feature flags into our demo app and pipeline using the new feature flag capability in AWS App Config. Firstly, there are a couple of different models for how to deploy feature flag configurations in a multi-account setup. But the one I like best is having a central configuration account that all other accounts query. In this setup, we have a version 1 of our to-do app config that has a feature flag turned off. Both our environments, dev and prod, are pegged to using version 1. The other new element we are introducing here is a completely separate pipeline for rolling out config changes. I like having a mono repo setup where your config and code live together, but having a different pipeline for rolling out config changes. The main reason for this is that your main pipeline running all test suites might take 10 to 20 minutes to complete, whereas turning on and off feature flags is something you want to be able to do quite quickly. So if we roll out a version 2 of our config, where the feature is enabled, as the pipeline runs, we'll see version 2 turn up in AWS App Config. But at this point, neither of our environments are configured to use it. And then as the pipeline finishes, we can optionally choose to update either the dev or prod environment to use that version of the config, hence enabling that feature flag just for a specific environment. So let's revisit our new feature from the schema change demo, where we added a description field to the to-do item structure. Can we make the rollout of this new feature even safer? So here in our code, we have the CDK infras code for our config. AWS App Config has a couple of domain concepts I want to explain. You have an application, which in our case is the to-do app. You have an environment, in which case we've deployed to dev. And then you have a version 1 of your config. So we've got our config object here, where we have an enable description flag, and we've set it to false. And next we have a deployment strategy. So this is how you can optionally roll out the flag to 10% of traffic, 20%, 30%. In our case, we're just deploying instantly. And then finally, we have this deployment construct that ties it all together. So for a specific application, specific environment, specific version of our config, and a specific deployment strategy, we roll that out. So we have a new pipeline here for our config. We roll that through our pipeline. And if we have a look at app config in the console, maybe this will help visualize that code a bit better. We have a to-do app. We have our to-do app config. You can see we have version 1 of our config, which has a flag enable description where it's turned off. And then if we jump back and have a look at environments, we've got a dev environment, and we can see that it's been pinned to version 1 of the config where the flag's turned off. So any queries from the dev account at this point will be getting a false for that particular feature flag. So now let's have a look at the code changes we need to make to support feature flags. If we jump into our create function for to-do, we've got this new block of code here that is querying the current state of the feature flag. There are some optimizations you can make with Lambda to do this. I'll leave that as an exercise for afterwards. And then we've got our conditional logic here where if the flag is enabled, we pass the description field into the create function. If it's not enabled, we ignore it. So if we roll out our application code via our mainline pipeline, push that out. At this point, we've got code running in our dev environment that supports the new feature, but when it queries for the feature state, it should be getting a false. So we can check that is the case. We'll run our test script again. We'll pass in the description field. And what you'll see is the create function doesn't return a description field in the response, and neither does it come back in the list operation. So let's go and turn this feature on. So back in our code, I have a version 2 of the config ready to go. Here we have a config object where we've set that to true. So one thing I want to point out here is that config versions are immutable. They're not designed to be updated. So you incrementally move forward. So we leave version 1 alone. We create a new version, version 2. We update our deployment to say this application, this environment, dev, it's now going to be using version 2, and our deployment strategy, which is deploy instantly. We roll that through our config pipeline. We've made no changes to our application itself. That main pipeline hasn't run. We have a look in the console again. We can see we now have 2 versions of the config, version 1 and version 2. Version 2 has the flag turned on. Version 1 is still there if we want to roll back with the flag turned off. And we can see against our dev environment that it is now pinned against version 2. And we can see the history there. It was previously on version 1. So now when the dev account queries our app config for the state of this flag, it should be getting true. And we can go and verify that with our test script. So now when we pass in the description field, we should be getting that back as part of the create function and as part of the list operation for those items that were created when the description field was enabled. So there we have it, feature flags from the pipeline. Thank you. Back to you, Brim, for the close.
Cheers. So let's recap the evolution of our pipeline. We started off with our basic pipeline, and we added in some external observability with Managed Prometheus and Grafana, capturing those metrics, doing that early so that we've got the data points as we expand on our pipeline. Then we added in our migrations, the code that James took us through, making sure that we've got that schema migration managed and the version between the environments. We then added in that resiliency test and made sure that our application code, when the unexpected occurred, behaved as we expected it to. And finally, importantly, putting in feature flags, a way of de-risking our deployment, especially having that separate pipeline there for the config itself. Now, we've only just scratched the surface in this short talk about the possible pipeline patterns that you could use. So I encourage you to have a look at the information that's available behind the QR codes there, including the code that James referenced earlier. And of course, there are other pipelines that might be relevant to you in your organization, such as blue-green deployments or canaries. And with that in mind, continue that learning journey you have. And I encourage you to visit the AWS Skills Builder, where we have over 600 free digital courses, hands-on labs, and role-based games. So look, thank you all for your attention and your interest today. I hope you gained some valuable insights through the talk. We'd really appreciate it if you go through and fill in the survey for this session. So once again, thanks again for attending, and I hope you had a good time. Let's go build.